In this problem, a lever is being used by a worker. They want to lift an object. The worker is able to apply a certain amount of force. What's the maximum weight that can be lifted? So we have a lever that has a total distance of 5.3 meters. There's a fulcrum, so there's a pivot point here. That pivot point and the object to be lifted right here, this distance is 1.3 meters. And so if we only have 5.3 meters remaining, that means on the other end here we have 4 meters. That's important because that's where our worker is going to push. So this worker is pushing down at this location in order to try to lift the object on the other end of the fulcrum. And so it's important that we establish the distance on each side of the fulcrum. So the worker has a maximum force of 540 newtons with a distance of 4 meters. And so how much force, what kind of weight can be lifted over here on this other side? And so what we need are two equal and opposite torques. So we're going to have here, we'll call this distance number 1, call this distance number 2. So on one side you have the force of the worker times that distance. That's got to equal the force that's going to be lifted, force number 2, times distance number 2 on the other side. And so we want to solve for that force number 2. That means I'm going to divide by distance number 2. And again, I could have plugged numbers in there at the beginning, but I like to move these variables around before I plug the numbers in, especially since you'll probably have different numbers if you're solving a problem similar to this. But the worker can apply a force of 540 newtons with a lever arm of 4 meters divided by the 1.3 meters from the other side. So 540 times 4 divided by 1.3. These meters cancel out. And so they can lift 16, we're going to round a little bit here, 1,660 newtons.